Alright, so in this video we're going to use the standard heats of formation, standard enthalpies of formation, to solve for the enthalpy of a reaction. So this is one of the three common ways. The other ways are Hess's law and using the bonds, and if you take a look we'll have two other videos on those. So the first thing we're going to need to do is, in this case, what's the enthalpy of combustion for ethanol gas? We need to write out the reaction of the combustion reaction for the ethanol gas. So we're simply going to write ethanol C2H5OH. Okay, we're just going to do this for all gas plus O2 gas, going to form CO2 gas like every combustion reaction, and water. Alright, so we need to balance it. We need 2 carbons. We have 6 hydrogens on the left. We're going to need 3. So 3 waters, that gives us 6 of those. Add up the oxygens, we got 3 and 4 is 7. We have 1 already, so I need 6, so I need 3 O2s. Okay, so I have this balanced now. Next step is going to be go and look up on one of the tables. You can look them up online, you can look up in the back of the book, but you need standard enthalpies of formation of these various substances. So the way that we do it is you just do products minus reactants. So the standard enthalpy of this reaction is going to be equal to, okay, that delta H naught F, the standard heat of formation of CO2 times 2 plus, let me put the number in front here, 3 times that of the standard heat of formation of the H2O. Okay, these are for gas, we should remember that. Okay, that's the products. We're going to subtract the reactants. Okay, so we need to look up the standard heat of formation of ethanol gas. And because O2 is an element in its most stable state at 25 degrees Celsius, it's going to be 0. You can look it up on the table if you want, so we don't really need to worry about that one. We can leave it out. So looking through this, the CO2s are negative 393.5 kilojoules, and that will get multiplied by 2, plus for the H2O, we've got 3 times, and that comes to negative 241.8 for the gaseous form. Kilojoules, sorry. Close that off, minus, and the standard heat of formation of ethanol as a gas, if we look it up, is negative 234.8 kilojoules per mole. Alright, so we go through, do the math on this, and what you get is the delta H naught of the reaction. So the standard enthalpy of this combustion of ethanol reaction is negative 1,277.6 kilojoules per mole is written. Okay, so that's how you find the, clarify that those are 7s. And so that right there is how you find the standard enthalpy of formation using the standard enthalpy of combustion for this reaction using the standard enthalpies of formation.